Hello students, in our today's class I'll introduce a new topic called silicones. Here these silicones, the polymeric organosilicon compounds, that means these are particular polymers obtained from silicones. Okay, so organosilicon means they consist of carbon unit also. So polymer means as many units of monomers combined to form a polymer. Okay, and they contain SiO-Si linkage. This linkage is particularly observed in case of silicons, and they have a general formula R2SiO, and this is a general formula for silicons. So why the silicon element is forming a polymer? So already I told you, from if you observe group 14 elements, from top to bottom size increases, and we know that this carbon and silicon are having small size and they form covalent compounds. So remaining elements forms ionic compounds or non-covalent compounds. So these elements, because of their covalently bonded nature, they can form polymers or different compounds. So now these silicons are classified into three main types. First one is linear silicons, second one is cross-linked silicon, third one is cyclic silicon. So linear silicon means all monomers combine in a linear chain formation. Okay, cross-linked means one chain of linked polymer is combining to another chain. So you can observe a cross-link between two chains. And here cyclic means you can observe the cyclic formation of the monomer units. Okay, so let us see the preparation of the silicons. So preparation of the silicons always involves three main steps. First one is preparation of intermediate, second one is hydrolysis of the intermediate, third one is polymerization. Okay, so let us see the preparation of linear silicons first. So here linear silicons also involves these three steps. First one is preparation of intermediate. We need to prepare intermediate which is useful for the polymerization process. So I am taking methyl chloride. So CH3Cl methyl chloride, 6 molecules I am taking. This 6 molecules of methyl chloride is combining with silicon, 3 elements of silicon in the presence of copper at 575 kelvins. A copper acting as a catalyst. So this is high temperature for this reaction, and these two molecules particularly combining and produces three different products. First one is methyl trichlorosilane, methyl trichlorosilane, and dimethyl dichlorosilane. Third one is trimethyl trichlorosilane. Okay, so among all these, this dimethyl dichlorosilane is a major product. So this is called as our intermediate. So this is 50%, is obtaining 50%, remaining are nearly 25 and 25%. Okay, this is a major product or major intermediate. Now I'll take this major intermediate and I'll do hydrolysis. So second step is hydrolysis of the intermediate. Coming to the next step, that is hydrolysis of intermediate. So the intermediate obtained in the first step, I'm taking that intermediate and I'm hydrolyzing, I'm passing through hydrolysis. So hydrolysis is nothing but addition of water. So here the Cl minus ions from this dimethyl silane is replacing with OH minus of ions of the water. So you are getting CH3 twice, SiOH twice, that is nothing but dimethyl silanol. So H plus ions of water combining with Cl minus ions and coming out as a 2HCl, that is a byproduct here. Okay, so now we are doing the polymerization of this dimethyl silanol. So polymerization is nothing but we are arranging the monomers in a particular order and we are removing the water from this arrangement. So we can see I am arranging the 3 molecules of dimethyl silanol and I am removing the water molecules particularly from this. So I remove 2 water molecules from this. So I am getting SiO-Si linkage. You can clearly observe. So finally we are getting the linear silicon polymer as a product. Okay. So this is just about the preparation of linear silicons. So next let us see the preparation of cross-linked silicons. So here also we'll have 3 steps similarly. First one is preparation of intermediate, second is hydrolysis of intermediate, third is polymerization. So let us see the first step, preparation of intermediate. So I am taking methyl chloride again. Methyl chloride, to methyl chloride I am adding hydrochloric acid 2 molecules and silicon 1. silicon 1 element. So I'm taking this and I'm heating in the presence of copper at 575 kelvins temperature. So now I'm getting methyl trichlorosilane. You can observe methyl trichloro. 3 chlorine atoms are there. Trichlorosilane. So remaining hydrogen is coming out as a byproduct, that is H2. So methyl trichlorosilane as an intermediate. So this is used for the aliphatic cross-linked silicones. So if you want to prepare aromatic cross-linked silicones, then we can take phenyl magnesium chloride, which is a Grignard reagent. So this phenyl magnesium chloride reacting with silicon tetrachloride and produces phenyl trichlorosilane. Okay, phenyl trichlorosilane, and we are getting magnesium chloride as a byproduct. So this is used for aromatic silicones. So now I'm taking hydrolysis of intermediate. So second step is hydrolysis of intermediate. So I'm preparing aliphatic cross-linked silicones. So I'm taking the methyl trichlorosilane. So methyl trichlorosilane undergoes hydrolysis and produces methylsilanol. You can observe methyl silanol is produced. 3 molecules of water we are taking here. So 3 OH ions replacing 3 chlorine ions, 3 chloride ions, and producing methyl silanol, and the 3 chlorine ions, 3 chloride ions reacting with H plus ions, 3 H plus ions coming out as a byproduct, that is 3 HCl. Okay, so now third step, I am doing the polymerization now. So I am taking the methyl silanol and I am doing the polymerization. So I'll arrange the methyl silanol molecules. So I'm taking here, you can observe clearly, I'm taking 6 molecules of methyl silanol and I'm arranging in the particular order. So linear chain is bonded with another linear chain through a cross link. So I'm arranging them in order to get a cross linked polymer. So we can observe here, linear chain, here one more linear chain is combining through this cross link, one cross link. Okay, so here I am removing 5 water molecules. You can observe here one water molecule, here one water molecule, here one, so here one and here one. So totally 5 water molecules are removed. So I am getting the cross linked silicon, that is with SiO-Si linkage. So you can observe. So when we remove the water molecule, we are getting SiO-Si linkage. So in between also you can observe SiO-Si linkage. So this is the preparation of cross-linked silicon. Coming to the last one, that is cyclic silicones. So we are seeing the preparation method of cyclic silicone now. So first one is preparation of intermediate. Similarly, whatever intermediate is there for linear silicone, same intermediate we will use for this cyclic silicone also. So firstly I am taking methyl chloride. I am reacting this methyl chloride with 3 silicon molecules, 3 silicon elements. So at 575 kelvins in the presence of copper, we are getting 3 major products, 3 main products will be obtained. So one is methyl trichlorosilane, second one is dimethyl dichlorosilane, third one is trimethyl chlorosilane. So here the major intermediate is dimethyl dichlorosilane. So now I am doing the hydrolysis of this intermediate. So I am taking dimethyl dichlorosilane. So to this dimethyl dichlorosilane, I am adding water molecules. So hydrolysis of dimethyl dichlorosilane gives dimethyl silanol. That means what? The chlorine ions are replacing with OH ions, OH minus ions. So we are getting CH3 twice, SiOH twice. So now the chloride ions are reacting with the remaining H plus ions and coming out as 2HCl byproduct. Okay, so now I am doing the polymerization of this dimethyl silanol. So I'll arrange in the cyclic way. That means in order to get a cyclic silicon, I'm arranging the 3 dimethyl silanols in the proper way. You can observe this as a cyclic model. So what I will do, after arranging them in the cyclic manner, I'll remove the water molecules. I'm removing the 3 water molecules from this structure. So finally, I'm getting a cyclic silicones as a product. So here also you can observe SiO-Si linkage in this particular structure. So we are removing the 3 water molecules, dehydrolysis process, and we are getting the cyclic silicones as a main product. So these are the preparation methods of linear cross-linked and cyclic silicones. So practice the reactions properly and understand each step. Okay, so then you'll get clear idea about the preparation. Thank you so much for watching.